Hello friends, welcome back to Formfully. In this video we are covering MCQ related to multithreading. We will covering theoretical as well as snippet questions. So let's get started with our first question. What is multithreading in Java? Options are a method that allows you to create multiple instances of a class, a technique that allows a program to perform multiple tasks concurrently, a way to create multidimensional arrays, a data structure for storing thread-related information. Multithreading in Java refers to concurrent execution of two or more threads. It allows multiple tasks to perform simultaneously, enhancing the overall efficiency and responsiveness of a program. Option A is incorrect because multithreading is not a method but a programming technique. Option C is incorrect as multithreading is not related to creation of multidimensional arrays. Option D is incorrect because multithreading is not a data structure, it is a programming paradigm. So option B is correct. Next question. What is race condition in multithreading? Options are a condition where two or more threads execute a section of code simultaneously, a condition where a thread is faster than other threads, a condition where threads never execute concurrently, a condition where a thread finishes its execution before others start. A race condition occurs in multithreading when two or more threads access shared resources or critical sections of code concurrently, it leading to unpredictable and undesired results. When multiple threads attempt to read and write shared data without proper synchronization mechanism, the outcome becomes dependent on the timing and order of thread execution, resulting in race condition. Option B is incorrect as a race condition is not about the speed of thread but about the interleaved and concurrent execution of multiple threads. Option C is incorrect because a race condition specifically refers to scenario where threads do execute concurrently and their interleaved execution causes unexpected behavior. Option D is incorrect as this scenario doesn't describe a race condition. A race condition involves multiple threads executing simultaneously and potentially conflicting with each other. So option A is correct. Moving to the next question, how can you create a thread in Java? Options are by instantiating a java.lang.thread object, by defining a class with the main method, by using the new keyword to create a thread, by calling the start method on any object. In Java, a thread can be created by instantiating a thread object and then invoking its start method. The thread class provides constructor to create new thread and the start method is called to begin the execution of the thread. Option B is incorrect because the main method is the entry point of the program but does not inherently create separate thread. Option C is incorrect as the new keyword is used to instantiate objects but it is not directly used to create a thread. Option D is incorrect as start method should be called on thread object to initiate its execution. Calling start method on any arbitrary object does not create a new thread. So option A is correct. Next question. What is the difference between extend thread and implements runnable when creating a thread in Java? Options are there is no difference, both achieve the same result. Extend thread is used for single threaded application and implement runnable for multi-thread application. Option C, extends thread allows you to override the run method while implements runnable requires you to define the run method. Option D, extend thread can only be used for daemon thread while implements runnable is for user's thread. So here the correct option is option C because when a class extends the thread class, it becomes a thread and you can override the run method to provide the code that will be executed by the thread. When a class implements the runnable interface, you need to provide an implementation for the run method. However, the class itself is not thread until an instance of a thread is created and pass the instances of a class implementing runnable in its constructor. Moving to the next snippet question. Here are the options of this code. Let's first understand the code. Here a runnable named R is created using lambda expression, right? This lambda expression represents an anonymous function with no parameters and a body contains a loop printing the value of I from 0 to 2. Then a new thread is created using new thread.start method. This start the thread and the run method of the runnable is executed concurrently. Now let's analyze the loop inside the lambda expression. It runs from I0 to I equals to 2, printing the value of I without a new line. So the output of the code is indeed 0, 1, 2 because the lambda expression represents a runnable that prints value from 0 to 2 in a loop. The runnable is executed by a new thread and the loop runs synchronously without any interruption. Therefore, the correct answer is A. Next question. What is a daemon thread in Java? Options are a thread that executes a daemon process, a thread with a lower priority than other threads, a thread that is automatically terminated when all non-daemon threads have finished, a thread that is created by executing the daemon thread class. In Java, a daemon thread is a background thread that runs in the background, providing a service to non-daemon threads. The JVM does not wait for daemon threads to finish their execution before terminating the program. When all non-daemon threads complete their execution, the JVM terminates and any remaining daemon threads are abruptly stopped. Option A is incorrect because a daemon thread is not directly associated with executing a daemon process. It is a type of thread within a Java program. Option B is incorrect as the priority of threads is separate concept from whether it is a daemon thread. Daemon threads can have any priority and their priority does not determine whether they are a daemon or user thread. Option D is incorrect as there is no specific daemon thread class in Java. Daemon thread are regular threads created using the standard thread class and their daemon status is set using the setDaemon method. In summary, a daemon thread in Java is a thread that automatically terminated when all non-daemon threads have finished their execution, allowing the program to exit. So option C is correct. Moving to the next question. Which of the following is not a thread state in Java? Options are new, terminated, runnable, finished. Finished is not a recognized thread state in Java. The correct state for the thread that has completed its execution is terminated. The thread state are typically represented by constant in thread.stateInum. This state includes new, runnable, blocked, waiting, time waiting, and terminated. New, a thread is in the new state when it is created but has not yet started. Terminated, a thread is in the terminated state when it has exited. Running, a thread is in the runnable state when it is executing in the JVM. Finished, as mentioned earlier, finish is not a recognized thread state. Next question. What is the purpose of synchronized keyword in Java? Options are it defines a static method, it locks a method to prevent multiple threads from entering it simultaneously, it defines a new thread, it specifies the priority of a thread. The synchronized keyword in Java is used to achieve thread safety by preventing multiple threads from entering a synchronized method or block concurrently. Option A is incorrect as the synchronized keyword can be used with both static and non-static methods to control access to critical section. Option C is incorrect because the synchronized keyword is used to control access to critical section in the code, but it doesn't define a new thread. Option D is incorrect as the synchronized keyword is not used to specify the priority of a thread. Thread priority is set using the setPriority method. So option B is correct. Moving to the next snippet question. Here are the options of this code. Let's understand the code first. Here the thread test thread class extend thread and overrides the run method to print hello to the console, right? In the main method, an instance of test thread is created with test thread t equals to new test thread method, right? The start method is called on the test thread instance t. This method initiates the execution of the thread and invokes the run method concurrently. Now considering the run method prints hello to the console, so the output of the code will be hello. There is no compilation or runtime exception in this code. The start method of the thread class internally calls the run method, and in this case hello will be printed the console. Next question. What is the purpose of wait and notify methods in Java? Options are: they are used to put a thread to sleep for a specified time. They are used for inter-process communication. They are used for inter-thread communication and synchronization. They are used to terminate a thread. The wait and notify methods in Java are used for inter-thread communication and synchronization in multi-threading environment. A wait method causes the current thread to wait until another thread invokes the notify method or the notify all methods for this object. Notify method wakes up a single thread that is currently waiting on this object's monitor. Option A is incorrect, as the sleep method is used to put a thread to sleep for a specified time, not wait and notify. Option B is incorrect, as wait and notify are specifically designed for inter-thread communication within the same process. For inter-process communication or other mechanisms such as inter-process communication or message processing would be used. Option D is incorrect, as wait and notify method are not designed for terminating threads. The termination of thread is typically handled using other mechanisms such as loop exit condition or explicit flag. So option C is correct. Next, what is the purpose of the join method in Java? Options are: to start a new thread, to wait for thread to complete its execution, to synchronize two threads, to make a thread sleep for a specified time. The join method in Java is used to wait for a thread to complete its execution before the current thread continues. When a thread calls join method on another thread, the calling thread is suspended until its specified thread completes its execution. Option A is incorrect, as the join method is used to wait for the completion of an existing thread, not to start a new thread. Option C is incorrect, as the join method is not used for synchronization. It is used to wait for the completion of the specific thread, not to synchronize threads. Option D is incorrect, because the sleep method is used to make the thread sleep for a specified time, not the join method. So option B is correct. Next question. What is the maximum number of threads that can be created in a Java application? Options are: it depends on the amount of available memory, 32, 64, 128. In Java, the maximum number of threads that can be created in Java application is platform dependent and is not specified by Java language specification. The actual limit is determined by the factors such as the available memory, the operating system, and the underlying hardware. Attempting to create a large number of threads may result in resource exhaustion, leading to performing degradation or application failure. So option A is correct. Option B is incorrect, as the number 32 is not fixed or standard limit for the maximum number of the thread in a Java application. Option C and option D following the same. In summary, the maximum number of thread in Java application is not specifically defined by the language and is influenced by the factors such as available memory and system resources. There is no fixed or platform independent limit imposed by Java itself. So option A is correct. Moving to the next snippet question. Here are the options of this code. Let's understand the code first. In this code, string s1 equals to hello creates a string literals in the string pool. String literals are shared in the pool, and when a new string literals with the same content is encountered, Java reuses the existing reference. In string s2 equals to new string hello explicitly create a new string object in the heap memory using the new keyword. This creates a separate object even if the equivalent string literals exist in the pool. So system.output.println s1 equals to s2 uses equals to operators to compare the reference of s1 and s2. Since s1 refers to string literals in the pool and s2 refers to the separate object in the heap, the result is false. The correct option is false. Moving to the next question. What is the Java memory model, JMM? Options are: a tool for analyzing memory consumption in Java applications, a specification that defines how Java handles memory and thread synchronization, a Java library for managing memory allocation, a feature for enabling garbage collection. The Java memory model is a specification that defines how Java programs interact with the memory system. It addresses issues related to memory visibility, automaticity of operations, and thread synchronization in the multi-threaded environment. Option A is incorrect as the Java memory model is not a tool but specification. Tools for analyzing memory consumption may include profilers or head dumps analyzer. Option C is incorrect because the Java memory model is not a library. It is a specification that describes the rules and guarantees related to how the Java handles memory and synchronization. Option D is incorrect as JMM is not a feature for enabling garbage collection. Garbage collection is a separate mechanism in Java responsible for automatically reclaiming memory occupied by objects that are no longer reachable. So, in summary, the JMM is a specification that defines the rules governing how Java handles memory and thread synchronization to ensure correct and predictable behavior in multi-threaded programs. So, option B is correct. Next question. What is the purpose of the thread local class in Java? Options are: it allows you to create new threads. It provides a way to access the global thread pool. It enables the sharing of data across multiple threads. It allows each thread to have its own instances of a variable. Here, the thread local class in Java provides a way to create thread local variables. Thread local variables is a variable that is local to each thread that accesses. Each thread has its own independently initialized instance of the variable. Option A is incorrect as thread local class is not used to create new threads. It is used to manage thread local variables within existing threads. Option B is incorrect because the thread local class is not used for accessing a global thread pool. Option C is incorrect as thread local class is designed to do the opposite. It enables the correction of variables that are local to each thread, preventing direct sharing of the variable state across threads. So in summary, the thread local class in Java is used to create a thread local variables, allowing each thread to have its own instance of a variable independent of the thread. So option D is correct. Next question. What is the purpose of java.util.concurrent package in Java? Options are: provides a framework for managing thread priorities. It contains classes and interfaces for concurrent and parallel programming. It offers tools for creating and managing threads. It is used for creating daemon thread. The Java util.concurrent package in Java provides a comprehensive framework for concurrent and parallel programming. It includes classes and interfaces for managing concurrent operations, thread pools, synchronization, and high-level abstraction for working with concurrent data structures. Option A is incorrect as the Java util concurrent package is not primarily focused on managing thread priorities. Thread priorities are set individually on thread and are not central aspects of this package. Option C is incorrect. Option C is partially correct, but the main focus of the Java util.concurrent package is not on creating and managing the thread directly. It provides higher level abstraction and tools for concurrent programming, such as thread pools, executor frameworks, and concurrent data structure. Option D is incorrect as java.util.concurrent package does not specifically provide tools for creating daemon thread. Daemon threads are created using the standard thread class and setting the daemon status using setDaemon method. So in summary, the primary purpose of java.util.concurrent package is to offer classes and interfaces for concurrent and parallel programming, providing developers with powerful tools for building efficient and scalable concurrent application. So option B is correct. Next snippet question. Here are the options of this code. Let's understand the code first. Runnable task is a lambda expression representing a runnable that prints numbers from 0 to 4 in a loop. Two threads, that is thread 1 and thread 2, are created both using the same runnable task. Thread 1.start and thread 2.start method start the two threads concurrently. Now the potential output depends on the thread scheduling, and due to the concurrent nature of the threads, the order in which the numbers are printed may vary. Here the options. Option 1 assumes that the entire loop of one thread completes before the other start. And then option 2, due to the concurrent execution of threads, the order in which the number are printed can vary. It could print 0, 1 from one thread and 2, 3 from other, or vice versa. Compilation error, there is no compilation error in this code, and also not a runtime exception. So the correct option will be option B, concurrent execution of thread it is showing. Next question. Which Java feature introduced a new way of writing parallel code and working with concurrency? Options are lambda expressions, generics, exception handling, enums. Lambda expression in Java 8 introduced a concise and expressive syntax for writing anonymous functions. One of the significant advantages of lambda expression is their ability to facilitate the development of parallel code using the Stream API. Option B is incorrect, as generics were introduced in Java 5 and are primarily focused on providing a way to create classes, interfaces, and methods with types as parameters. Exception handling mechanisms such as try-catch blocks and the throws clause existed in Java prior to Java 8, while Java 8 introduced some enhancement to exception handling, example optional class for better handling of null values. It is not specifically feature introducing in a new way of writing code, parallel code. Enums were introduced in Java 5 and provide a way to define a fixed set of constants. So in summary, lambda expression in Java 8, especially when used with the Stream API, revolutionize the way parallel code is written, making it more concise and expressive. So option A is correct. Moving to the next question. What is a fork join framework in Java? Options are a framework for managing thread priorities, a framework for parallel processing and task decomposition, a framework for creating single-threaded applications, a framework for asynchronous programming. A fork join framework in Java refers to fork join pool and related classes introduced in Java 7. It is designed for parallel processing and task decomposition, allowing the efficient execution of parallelizable tasks by dividing them into smaller subtasks. Option A is incorrect. The fork join framework is not primarily focused on managing thread priorities. It is designed for parallelizing tasks and efficiently utilizing available processors. Option C is incorrect. The fork join framework is specifically designed for parallel processing and is not intended for creating single-threaded application. Option D is incorrect. While the fork join framework involves parallel processing, it is distinct from traditional asynchronous programming framework. Asynchronous programming often involves callbacks, futures, and reactive programming construct. So in summary, fork join framework in Java represented by fork join pool is designed for efficient parallel processing and task decomposition. So option B is correct. Next question. What is the purpose of java.util.concurrent.logs package in Java? Options are: it contains classes for creating custom exceptions. It provides classes and interfaces for advanced thread synchronization and logs. It is used for creating thread pools. It is for managing thread priorities. The java.util concurrent logs package in Java provides a framework for more advanced and thread synchronization than what is offered by traditional synchronization provided by synchronized blocks and methods. Option A is incorrect, as the java.util.concurrent.logs package is not focused on creating custom exceptions. It is specifically designed for providing advanced thread synchronization mechanism. Option C is incorrect, because this package is not primarily designed for creating thread pools. Thread pools are typically managed using executor framework, which is part of the java.util.concurrent package. Option D is incorrect, as the java.util.concurrent.logs package does not provide tools for managing thread priorities. Thread priorities are set individually on threads and are not central aspects of package. So in summary, java.util.concurrent.logs package is used for advanced thread synchronization and provides a variety of log implementation to achieve fine-grained control over thread access to share resources. So option B is correct. Moving to the next snippet question, let's understand the code first. Here int x equals to 10. This line declares and initializes a local variable x with value 10 in the main method, right? Runnable are this line creates a runnable with lambda expression that prints the value of x. Correct. The lambda expression captures the variable x from its surrounding scope. R.run method, this line invokes the run method of the runnable, and inside the lambda expression it prints the value of x. Now the output of the code will be 10. The lambda expression can access and use the variable x from the surrounding scope, and it prints the value of x, which is 10. So option A is correct. Thanks for watching.